So this is a quick video about checkpoint 3 and a little about checkpoint 7. Both of these are about interpreting the graph that you made from your experiment. I'm first going to talk about this paper helicopter experiment, and then we'll talk about the experiment that you did yourself. So the checkpoint 3 looks like this. It says, start here, write a slope statement. And the goal of checkpoint 3 is to write at least 2 paragraphs to basically say what the pattern in the graph that you're seeing really means. And I think this is actually really important to keep in mind. If you had to tell a 5-year-old how a helicopter with a higher slope value behaves, is it faster? Is it slower? What would you say? If you had to make it as simple as you possibly could, what would you say? So in order to think about that, let's look at an example of a graph. Your graph probably doesn't have exactly the same slope as this, but it does have, the same independent variable, drop height, and the same dependent variable, drop time. So I've included these here, IV name, IV unit, DV name, DV unit, to help us think about how to write the slope statement. Because the first thing to do in checkpoint 3 is to write the slope statement. So if we have a graph like this that's telling us the IV name, drop height, and the IV unit, hands, or in some cases we measure it with feet, we can start our slope statement in exactly this way. For each additional 1 hand of drop height, we're using the unit first, then the name of the variable, both coming from the independent variable axis, which is the one on the bottom. So for each additional 1 hand of drop height, the drop time increases, and then we have to put our slope value in. So this is where yours is going to be specific to your graph, but after you've calculated the slope, you'll say, okay, well, it increases 0.4 seconds, or 0.22 seconds, or whatever your slope is. And that will help you think, okay, what does that mean about the helicopter? If I drop it from a little bit higher, it takes 0.4 seconds longer to fall. Well, if that number was bigger, I guess that would mean if it was falling slower. If I change the slope to, for each additional 1 hand of drop height, the drop time increases 2 seconds. If it took 2 seconds to fall each additional hand, that would be a much slower helicopter. So coming back to this question, if you had to tell a 5-year-old how a helicopter with a higher slope behaves, we're seeing that it would actually mean a slower helicopter. When you have written a couple sentences, 2 or 3 sentences on paragraph 1, and these sentence stems are here to help you, try to write a couple sentences on paragraph 2 as well. As shown in our graph, points for the same drop height value show a range of values for drop time. Points, if we look at this, points for the same drop height, like right here, all of these points are 5 hands of drop height, show a range of values for the drop time. This is called uncertainty. And all of these sentence stems are about this concept of uncertainty. Why does it make sense that even though we drop the helicopter from the same height, the time is actually different each time? So write 2 or 3 sentences here and you're done with checkpoint 3. I would say if you're working on checkpoint 3, stop the video now. Go back and work on checkpoint 3, finish it. You could even watch the video again and step by step use what I've said to finish your own checkpoint 3. That's your first step. But I'm going to go on now and talk about checkpoint 7 as well. Actually, I'm going to make that a different video. I just decided. Bye.